I still think that American was harder than college, like in terms of how much they demand of you. College is a different thing, but American is just, it's unlike any other high school. I met so many other people in college, and I'll be like, "Oh, what do you think? Do you think high school is easier or college is easier?" And they're like, "Oh, high school is much easier." I'm like, "What the hell are you talking about?" Like, I would stay up till 3 a.m. every day, get 3 hours of sleep every day. That was a ritual.
What classes did you have that it was
At
fun?
American,
An
at
American?
American,
Yeah.
um, what
Like
year are you in right now?
I'm assuming this was like junior year or something that you couldn't sleep.
Junior year was definitely a sleepless year. Yeah. There was one
Yeah.
point junior year that I was like sitting in the hallway and I swear to God, I thought it was raining indoors. Like it was just, I had not slept in 24 hours and it was just, I think actually I'd slept 2 hours in the last 48 hours. And it was just absurd. I took, let's see, I took, of course, I took AP English Lang. I took honors pre-calc, A push, psych, not the AP, not the AP psych. They had that next year. Um, shoot, what are the junior year classes? The normal classes. I'm missing like 2 subjects. I don't know what they were.
I don't know. Maybe you'll remember like as you go on. But
Yeah.
I think we're good on our end. So like whenever you want to start, we're good. Oh, and to anyone
Cool.
else, if you have questions, then you can either like DM me or Joyce, and we'll ask them at the end. So
There's also pieces of this that I'm gonna talk a little bit about math. So I'm also happy to take questions during those parts too, just to.
I think you should be able to direct message Shaan as well. So
Cool.
or you can drop in that in the chat.
All right. Okay. So hi guys. My name is Shaan Mathur. I'm I'll get to who I am, but I'm here to talk about deep learning. I went to American, and I kind of wanted to come back and tell you guys a little bit about the stuff I started becoming passionate about. So I'm excited to share this stuff with you. So again, my name is Shaan. I'm an AHS alumni. I graduated in 2015. I went to UCLA afterwards and got my bachelor's in computer science. I actually didn't apply under computer science. I had to transfer in. I was originally in business economics, but I realized I really liked CS, so I switched in, and it was a great decision. And I graduated from UCLA just a year ago, and now I'm doing my master's, and hopefully we'll be completing it this June. I've done research in CS and theoretical computer science. I've been a TA in theoretical computer science for a couple quarters now. I do research in deep learning now, and also in adversarial robustness, which I'll also talk about at the end. And I'm also working on a deep learning startup to make it easier to share private data. So we'll talk about that too. So I feel like a lot of people that I meet don't know what deep learning is, and it always shocks me because it is so critical to know what it is, because it is an essential part of the future, and it is even everywhere today, but we just don't see it. Deep learning is a major part of the whole home assistant stuff that industry is pushing out, like Google Home. Whenever you talk to Google Home, how is it able to translate your voice into text? How is it able to translate that text into understanding what kind of commands you're saying? There's many ways to say, turn on the lights, many different ways to structure that sentence. But somehow, out of all those ways, it's able to funnel it down to one inherent meaning, turn on the light. And there's other things like talking to Siri or all these natural language processing skills. This is all deep learning. There's facial recognition, being able to take an image and being able to draw a box around someone's face. Or if you're using Snapchat, Instagram, or whatever filters, and they convert your face into something funny, they have to be able to figure out where your face is. And that also is deep learning technology. Self-driving vehicles. The fact that like you have a camera that looks at the road, understands the rules of the road, is able to look at various objects within its field of view. And from that, be able to do something as complex as stopping at a red light, stopping at a stop sign, making a right turn when it's allowed to. All these different complex commands are built above deep learning. And deep learning can do other really cool things. If you have these old images that were originally black and white, you can recolor them using deep learning. So these were originally black and white, and you're able to recolor them. It doesn't seem like there should be enough information to do that from black and white photo, but there is. Deep learning is able to extrapolate that. Deep learning can create art, really, really beautiful art. So if you take these two images, not generated by a deep learning machine, two images of a girl, and you want to take the top image and put it in the style of the bottom image, deep learning machine can do that. And it creates really, really beautiful, beautiful artwork. And it can generate fake faces. All of these faces are not real, of not real people. They're people who don't exist, generated by a deep learning machine. I find this GIF really fascinating because you can see it's like the space of faces is continuous, very small increments in the face, and you keep doing that over and over, and you start creating new faces, all different kinds of faces, different gender, different race, different age. It's really incredible, and none of these people are real. And then, of course, you know, in today's world, there's going to be technology built off deep learning to revolving around COVID. I mean, you can have face mask detection, which is should be a pretty simple extension of doing facial recognition. And I think even Disney World is reopening, but they're going to digitally add masks onto the faces of people on the rides. And that's going to be deep learning based, because that's how you are able to do facial recognition, through deep learning. So clearly, this subject is pervasive, but what is deep learning? So you might have heard of something called neural networks in the computer science domain. And of course, their name is inspired from biological neural networks. So to understand where the inspiration for neural networks came from, it's helpful to understand the biological version first. And it's going to be a great simplification of what biological neural networks do. But basically, you can break apart a neuron, biological neuron, into 3 parts. And if you love bio, I am sorry, I'm going to do this, but this is going to be the simplification. So there's 3 parts. There's the dendrites, there's the axons, and then there's the axon terminal. So the dendrites, it's like the input of the neuron. It has all this tree-like structure that each dendrite, each branch in the dendrite receives an input signal. And all those signals go through the dendrites and go through the middle portion, which is the axon hillock. And that kind of sums up all of these input signals. So the strength of the signals are all summed up. And then at the axon terminal, this is where the neuron sends out signals to the other neurons around it. And what it does is, if you reach a certain threshold, if the axon hillock sums up the input signals and it exceeds a certain threshold, then you're going to output some signal to another neuron. So to summarize, you have inputs, those inputs are summed up, and if you reach a certain threshold, you output something. That's the abstract model of a biological neuron. And by the way, if you guys have questions on this part, feel free to message in the chat, and then maybe one of our hosts can let me know. So given that structure of a biological neuron, we try to create something called an artificial neuron to help us build deep learning models. And so again, kind of like the dendrites receiving inputs, we're going to have some sort of inputs. We don't really know what they are yet, but let's just call them X, X1, X2, X3, so on. We have n different inputs to our neuron. And so they're all coming in. And just like the axon hillock, we need to sum them all up. So we're summing all of these inputs together. But here's one thing that's not really complete about this picture, is that different neurons have different strengths connected between them. So some of these arrows might be stronger than others, and some are weaker than others. So to get that, we want to have weights associated with each branch. Stronger connections means higher weights. Weaker connections mean lower weights, maybe negative weights even. And so what we have here then is this, a sum over a product of weights and their respective inputs, wi, xi, summed over all of the elements. So it's a summation. And then what do we do? Well, if you reach a certain threshold, you want to output a high value. And if you don't reach that threshold, maybe you output another value. So you have some sort of curve function here. It's kind of like it's called a sigmoid function. Well, we'll just call it sigma for brevity. And that is our output. So again, the x is the input, the weights represent the strength. You sum them all up. If you reach a certain threshold, you output that value. This is the artificial neuron. This is the fundamental building block of deep learning networks. Also, in case you know anything about vectors, if you know something called a dot product, there's something called a dot product of vectors. This is the same thing as a dot product. So we can write this out as a weight vector, which is all the weights, and an x vector, which is all the x's. This is just by definition of what a dot product is. I hope this makes sense. I don't have access to my mouse. Did somebody ask a question in the chat? I saw something.
Yeah, someone asked, the threshold is the y value on the graph, right?
Yes. Yeah, so like as your sum value is the x value. So the larger your sum, the more right you're going. And the smaller your sum, the more left you're going.
And then I think someone asked, what's the point of the sigmoid function?
The point of the sigmoid function is to model just like what the biological neuron does. The biological neuron says, if the input signals are strong enough, then we're going to output something. And if they're not strong enough, then we're going to output some small value. So it's like a step function almost. Good questions. Okay, so this is the fundamental building block. And then what can you do with this? Well, you can do the following. So again, same diagram, just with circles. You have inputs going in, you sum them all, then you output with the sigma function. You can just do the same thing with another neuron using the same inputs and a whole bunch of neurons. So each of these is doing the same functionality. They're just a bunch of them now connected to the same inputs. And so all of these are going to be their own little function, little outputs y1, y2 through ym. So it's just a repetition of the same idea. And it turns out this, and don't worry if this is too much, but this is the same thing as a matrix multiplication, because we had a bunch of weight vectors and doing dot products with x. Now we're doing a matrix multiplication against x, where w is all the weight vectors.
Or are those
and say again?
Are the vectors multiplied or added to find the value of w?
So it's like if you have a matrix, each row is a vector. So each element in the row is a vector. Yeah.
Oh.
Yeah, and by definition of matrix multiplication, this product is going to be Y1, Y2, Y all the way to YM, top to down. And this, by the way, is also one of the reasons why linear algebra, or the study of matrix multiplications and linear transformations, is so pivotal to understanding deep learning, and is a subject I would recommend you guys explore sometime in the future. Okay. So then once we can do that with layers, we can stack neurons to make layers. We can just stack layers onto each other, connect all these layers to each other in the same way. Like as you're outputting towards the right, you're connecting that output to a bunch of things in a similar way. Oops, now I have to go through this. In a similar way that we connected these two layers together, we can repeat that with other layers as well, using now the outputs Y1 through YM as inputs to the next layer. And we could do this repeatedly, as far as we want to go. And this is what is called a deep neural network. Deep because we have a lot of layers connected. And this is like what started it all, pretty much. And this is basically this really complicated expression of just a bunch of matrix multiplications and then sigmoid functions, matrix multiplication, sigmoid function, over and over and over. So that's all nice and well, but I didn't really describe how you choose the weights. So I'm going to give a very abstract idea of what happens. So let's say we want to recognize handwritten digits. So we have handwritten digits and we want to be able to classify them as what number is written here. So first thing we do is, given a single image, we put it as the input value to the neural network. And that neural network is going to output something. And it's probably going to output something very wrong in the beginning. But then what we do is we say every time they output the wrong answer, calculate small changes to the weights that we can do that would improve the performance. And so we get feedback from our wrong answer, and we end up twiddling each of the weight values just a little bit. So that way the output will improve just a little bit. And we do that repeatedly and repeatedly until finally we have something that outputs the right answers on this set of data that we have beforehand. And now we should be able to deploy this in the real world. And you write a digit down, this model will do a pretty good job of classifying it, because it does really well on classifying using the training data that we gave it. So that's all the math I'm going to go over. So now I just want to talk a little bit about what the future holds because of deep learning. So there's the automation of skilled labor. So people used to think that computers were great, but they wouldn't ever really, there was something fundamentally missing, that they couldn't replace humans. And I think it's becoming increasingly obvious today that this was wrong. This is a wrong assumption. And computers will be replacing people in a lot of areas, even in healthcare. I mean, some neural networks can already outperform doctors in performing diagnoses. So if a neural network can provide a consistent and high quality result in performing diagnosis, I could see a world where we would prefer a neural network to give a diagnosis over a fallible human. There's already chatbots that are built to intelligently identify patterns in patients' symptoms. These chatbots talk to you, they understand what you're saying to them, and from that, they're able to identify, okay, what symptoms do they have? And because of these symptoms, what do you think their problem is, and which doctor should we forward them to? And industry is trying to get into healthcare right now because they know this area is going to be very hot. So Amazon is trying to get into healthcare, and I wouldn't, if they're successful and they're getting their hands in everything now. So I wouldn't be surprised if they did. And it could be one day that you end up asking Alexa for medical advice. Maybe Alexa will be connected to your medical data somehow. that's a world that is possible with given technology today. But a big issue in healthcare is that medical data is everywhere, but medical centers don't like sharing that data. I know this because I'm trying to do a startup in the medical arena, and everyone loves their medical data. They're like, it's mine. And they know how valuable it is, because if you have all that data, you can create machines that can diagnose disease. You could use deep learning to accelerate research into figuring out cures for diseases. So it's very valuable data, so they don't want to share it. So that's a big issue right now. My startup is trying to figure out if can we fix that. But yeah, that is one hindrance to this. Another area is personalized recommendations. And I think you guys especially probably are more familiar with this because you're growing up in a world where this is starting to be really a part of your core social media life. When you Google search something, Google search has been upgraded to incorporate the search history of other people to help make better search suggestions and links for you. It used to not be the case. Google used to be implemented with an algorithm called PageRank, which would basically say, if given an internet web page, that web page is important if a lot of other websites reference it. And so they would rank pages based upon that, like how many pages reference this web page. If a lot do, it's probably important. It should be a top result. Google doesn't do that anymore. Google uses deep learning to understand what people are looking for. And by understanding what people are looking for, they can try to provide better search suggestions and links. Netflix, YouTube, other streaming platforms, I'm sure you guys are all familiar that they use your history, your search history, and history of similar people to try to make recommendations for you. In my opinion, YouTube is very terrible at this because I end up looking at the same kinds of videos all the time and I want some diversity. So there is some downsides to that. But that whole platform is built upon deep learning and machine learning. And the world is becoming more and more, having more and more data about us all the time. And it's just going to get bigger. And by the time you guys are adults, there's going to be so much data about you. And all these companies are going to eat it up and try to create personalized recommendations based upon that data. And that's a future that will happen. It's inevitable. I think I have one more bullet here. Nope. So there's other thoughts. I know Obama has some. So I'm going to play a little clip here. Watch your volume.
We're entering an era in which our enemies can make it look like anyone is saying anything at any point in time, even if they would never say those things. So, for instance, they could have me say things like, I don't know, Killmonger was right, or Ben Carson is in the sunken place, or, how about this, simply, President Trump is a total and complete. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele.
So it's really frightening that we're able to do this now. This is something called a deep fake. And this is also deep learning technology. And this is going to become a problem. It will become a problem within the next 20 years. You're going to have fake news stories where you have politicians. I mean, if you look at this video, even maybe Obama's voice, maybe you could tell kind of that there was something off, maybe. But his lip sync with the audio was impeccable. It really was really impressive. And there also is techniques to emulate Obama's voice audio. And it's so well that MIT posted a fake deep fake using that, but they actually had to degrade the quality of Obama's audio to prevent people from using it maliciously. That's how good the technology is getting. They have to purposely make it bad so others won't use it poorly. So you can imagine a society, a dystopian society, where you have fake news propagating all the time, people faking politician speeches, people making politicians do things in videos or celebrities do things in videos that they didn't actually do, but the video seems like it's the case. Luckily, right now, most people don't do that. Well, people instead do stuff like this.
Whatever happened to predictability? The milkman, the paperboy, evening TV.
That's Ron Swanson, by the way. Okay, so that's like what people are doing. So we're okay right now, but it is scary, that technology, and this is deep learning again. And the last thing is about the vulnerabilities of neural networks. Then this is a topic called adversarial robustness. We have, these neural networks are so impressive. I mean, they can diagnose cancer, they can classify whether an image has a cat or a dog in it. They can do really impressive things, but it turns out that they're brittle. You have here a example of a neural network that originally classifies the leftmost image as a panda, but then you perturb the pixels in this image in a very strategic way, and suddenly it thinks it's something else completely different. And this is kind of scary because our society also is becoming more and more dependent on deep learning. What's going to happen when somebody tries to exploit this vulnerability to make machines do things that they weren't supposed to do? For example, researchers figured out a way to put quote unquote adversarial patches on the stop signs so that a self-driving vehicle would not be able to tell it's a stop sign. It'll think it's something else. Maybe it'll think it's a speed limit sign, and it'll tell the car to drive faster. So there's serious dangers here as well. And part of the future is trying to guard against these failures, these potential failures, because this is the society we are heading towards. Deep learning is inevitable. It is something that's coming, and it's beautiful. It comes with such wonderful new technology, and it's going to really improve society. But with that, it also brings us possible dangers too. It's the next major leap for humanity. One of the leading researchers in deep learning calls deep learning the new electricity. And it's that important of a human discovery as electricity, because it's going to lead to a tremendous new stage of our lives. So I think it's our responsibility to try to join this progress and also try to put in our ethical restrictions upon it, so that way we can make sure the world's a little bit better place. So I want to thank you guys. This is all I want to talk about today for deep learning. I'm happy to answer any questions, and I hope you guys are excited about the topic.
Yeah, thank you, Shaan, for presenting. If you guys have any questions, you could put in the chat. So I heard you have a startup. What exactly are you doing with the startup at this current point?
Yeah. So I'm doing a startup in basically data privacy, and it's a deep learning based startup. So basically, in the same sense, earlier I showed that it was possible for deep learning to create images of fake people. That was a possible technology to make. In the same sense, and the way it did that was it took a bunch of images of real people. It learned what do people look like, and then it was able to generate plausible looking images of people. So one idea in the medical field is that people don't want to share data because of patient privacy concerns. So to avoid that, instead you could train deep learning to learn what patient data looks like, and then make it generate fake patient data. And that fake patient data might have the same statistical properties as the original patient data, but it's not linked to anyone's identity. And so you can share that fake stuff freely and keep the real stuff secure. So that's the general idea of what we'd like to do.
So someone asked, is it possible to maintain ethics of deep learning for the future?
Can you repeat that?
Is it possible to maintain the ethics of deep learning for the future? Is it?
It's a good question. I mean, it's really tough. It's really tough. One possible way of upholding ethics is to try to build more robust systems. For example, with deep fakes, for example, that's a real ethical dilemma. One thing that we might want to do and invest our time and money in is trying to build better systems for detecting a deep fake. So given an image, can you tell if this image was doctored or is it real? And that's one way of doing it. And that seems like a good approach, but it also is problematic because the way deepfakes are made, they actually do, you can actually use the detector to improve the deepfake generator. So it's like a cycle of cat and mouse. And like you might try to beat the system by making deepfake detectors, but then that'll just make the deepfakes better, which means you have to make better detectors, which makes them better more. It's just so that like that's not the right way to go about it ethically. I think it might be that there has to be legal things, and I think Congress, if they ever do anything, we'll have to figure something out in this area. But I don't think they even know that this is a real threat yet.
I think also in the chat, someone asked, you went to college for econ and then switched to CS. So what motivated this decision, and what in general motivated you to go into AI and like theoretical science?
Mr. Holcomb. Just kidding. I mean, I took a PCS with Mr. Holcomb. He's a great guy. It was the first time I ever learned programming, been introduced to the topic at all. I tried to avoid it like the plague before I took APCS, which was my senior year. But I gave in, mostly because I thought it was supposed to be an easy AP class because it was Mr. Holcomb. But, you know, I ended up really enjoying the subject. But at that time, I had felt that I wasn't ready to make an application for CS because there's so many students in the AI club or CS first club that I felt had better qualifications than me. And I may have been wrong. I may have been wrong about that. Maybe it would have been fine. But I decided, okay, I'm still going to continue with my path, apply under econ, business economics. And then I tried to transfer when I got to college, which is not an easy process. I had to maintain a certain GPA for multiple quarters and then do a final application to school. And I got in because I met those requirements.
That's really cool. I also had a question. So you had a startup. What do you think, what advice would you give to anyone who was like looking to start up something, and what were some of like the biggest challenges that you faced? Like what or like are facing while you were doing this?
Yeah, very good question. So there's several recommendations I would make, and like several things that I would want to have changed for myself if I did it all over again. I've tried several times to start something up. This is not the first time I've tried. This is the most legitimate startup I have, so to speak, because we actually got into an accelerator program. But all the other projects I did, like I tried to make a video game with some friends. I tried to make a music synchronization app across different speakers, so that way you can have a home system. I've tried a bunch of things. I think your team matters a lot, and I don't think you should ever underestimate how important that's going to be. When I did the video game, I teamed up with my friends, and that was not a good idea because my friends didn't really care. Like they were just in it just to do a project, but they didn't they weren't invested in it like I was. And so it ended up flopping because you can't hold up a project by yourself. I tried a different approach with music synchronization. I tried to find a random stranger to do it with, and it was okay, but then like even we didn't have the compatibility together. Now what I'm doing is like I am doing it with one of my friends. But I have also 2 other MBA students. But I'm finding the problem is that I'm the only technical person on the team, and it's hard to do that when you're alone. It's much easier to work with someone else and have other people who care about the product as much as you do. So I think really my one piece of advice is find co-founders that care about the product as much as you do and can contribute as much as you contribute yourself, because that will lead to success. When you're tired, they'll pick it up for you. When they're tired, you'll pick it up for them. You know, it really is teamwork, and it really, really does matter.
Yeah, that's true. So there was another question that asked, do you think that the dangers of deep learning will eventually overtake the helpfulness that deep learning provides? And if deep learning were to become very dangerous in the future, what are some ways that we could deal with the danger, or are we just doomed?
As to whether it is like whether the dangers outweigh the benefits, I think it's really hard to answer ethical questions like that, because it really depends on what your code of ethics are, what your code of ethics really are. Deep learning has a lot of real world benefits that can save people's lives. I mean, you can have even the healthcare applications. You can create better diagnoses. Deep learning methods could eventually lead to new vaccines for diseases. It could lead to empowering researchers to use data in a way they never thought they could before. So there's a lot of real benefits to it, but the downsides are definitely there. It's tough. It's tough to answer that question. I'm not really sure. It's like we're being introduced to this wonderful new technology that helps in a lot of ways, but it's going to create a society with other problems. But I also at the same time think that that's how society is. Society evolves, new technology comes, new problems come. We live in a world that I think we take for granted, that social media is so prevalent. But we used to think before, I remember when Facebook first happened, we used to think like, this is going to be horrible. Nobody's going to talk to each other. This is a real problem. And it is a problem, but it's a problem. It is a problem today, and we deal with it. And I think deep learning is the same. These are going to be new problems that we're going to have to deal with, but we're also going to gain the benefits of it. I think that's the best I could answer for that.
That's really cool. Honestly, do you think the benefits outweigh?
I think that I think personally that the benefits do outweigh, because I'm a person who really likes pushing technology and pushing human knowledge. Like I think that's critical, and it's kind of one of the most important reasons why, in my opinion, one of the most important reasons why we're even around, because the fact that humans exist is just a completely big accident. And like, what do we do with our existence? I mean, as a species, we've been pushing the boundaries of knowledge. I think deep learning will be a key stepping stone towards greater artificial intelligence that may eventually, supersede us, and that will be humanity's biggest accomplishment, I think. And this is a step towards that, and I think it's a necessary step towards that. So in that sense, I do think the benefits outweigh it, because this is such an important step in human knowledge. But there's a lot of other perspectives you can argue that it's not worth the benefits.
Kind of like on the danger topic, someone asked, why isn't deepfakes more common in politics and news?
Because I think that it requires a certain level of expertise to do it. I mean, this is also cutting edge research, but at the same time, there's deepfake generators out there that are accessible to the public. I also think that we haven't gotten to the point where it's just plain indistinguishable from reality, from like a real video, that you can kind of tell that something's wrong. But I think that we're going to close that gap real soon. So the only thing hindering it from being prevalent is how accessible is it to regular folk who don't need to know why it works, who just want to create malicious content. But that's going to happen. It will happen because somebody will do it.
And then another question, are statistical significance tests, type 1 and type 2 errors, frequently used with deep learning outcomes?
Yeah, all that stuff is like in the realm of machine learning, which is a superset of deep learning. Deep learning is a kind of machine learning, and understanding type 1 errors, type 2 errors, and all that stuff. I'm not going to pretend like I know it too well because I'm still studying this stuff, but it is important to creating better machine learning models. So doing stats and stuff, that does help for machine learning in general.
So someone asked that, like, in general, what do you think the future of deep learning would look like?
I think expect a world where your data is used to make highly personalized content for you. Kind of like on the same level of like Netflix recommending you videos and stuff, expect recommendations on other things that your data is now going to be exposed to. The more social media you join, the more different stuff you register your email under, the more data is being tracked about you. All that can be, not that that's necessarily bad, though it could be, but that data being tracked about you will be used to create recommendation systems that are highly personalized for you, content that's highly personalized for you. And at the same time, we're also going to have, stuff like the deep fake generators. All that stuff is going to be, we're going to have really cool new memes. I mean, like we can have really funny deep fake videos. We're going to have, there's going to be a lot of cool content out there at the same time. I'm only talking about the negative stuff because I think it's important to understand it. But yeah, that's kind of what I think.
Someone also asked, this kind of goes into like same thing. Couldn't you make a lot of money by creating a deep learning thing that takes in data and then sells the data? Like all of like the big YouTube, Spotify, those people like selling data and stuff. And I think they also said that you mentioned Alexa regarding medical data. So couldn't that like also be bad as well?
So is the question asking like, can you monetize data? Is that what the question's asking?
I think it's in the chat as well. The first question was, could you make a lot of money by creating a deep learning thing that takes in data and sells the data?
Right. I mean, like, I think what that question's getting at is like about the value of data. I don't know what the deep learning aspect about that would be, but certainly like a lot of companies are profiting off of selling data about people. If you're talking about like extrapolating more, like from data, extrapolating even more data about somebody, that could definitely be a thing. Yeah.
And then I think in the second part of the question was, what are your thoughts about, do you think Alexa being able to give you medical advice, considering that it has to like take in medical data and it's exposed to that, do you think it would be beneficial or like dangerous? Because like the data could be sold or something.
Right. I'm not a fan of Amazon, if I'm honest. I don't think that having one tech company in control of so much stuff is going to be a good thing, because they might be nice to us right now, but it won't be it may not be nice to us later on down the road because they have so much power, because they have so much data. So I would not be a fan of Amazon being in control of my medical data, because they might be able to use that later down the road for other stuff that they want to do. It puts them in a lot of position of power, which maybe is not clear how they'll use badly, but it's possible. And it also is bad for the economy, I think, because there shouldn't be one monopoly who owns everything. So in terms of sense of economics, I don't like it. In terms of the ethical aspect of it, I think the idea is cool that you could be able to talk to a home assistant and like tell them like your medical concerns, like, hey, I'm feeling this, this, and this. Given what you know about me, what do you think's happening? And maybe they know your medical history. They'll incorporate that, understand what symptoms you just told them, and then help you, give you a diagnosis. It's almost like WebMD on steroids. But do we need Amazon to be directly in control of that? I don't think so. I think you could have a third-party company who Amazon uses an API to connect to them, and like that company is in control. Maybe they're a medical institution or something. Yeah, I don't know if that really answered the question, but
No, I think that answered. And then there's also, I know you talked about this, but someone asked how dangerous would it be if high quality deepfake generators got into the hands of the general public?
I think it could be pretty dangerous. I mean, I go on Twitter, like I go on Twitter a lot for politics, which is probably a bad idea, but I go on there just to see what people are talking about. There's so much fake news, so much misinformation being spread around, and people share photos of things that didn't actually happen, that are photoshopped in some way. It's just a lot of misinformation. So if these people learn how to use deepfake generators to create content that they want to push, misinformation that they want to push, that's not going to be good, because it's just going to lead to mass confusion about what is the truth, what actually is going on. Because normally we look at videos and we take videos as the truth. There's no way to really fake a video, so we thought. So it could be bad.
And then this kind of also goes into like the future of deep learning. But someone said, what are some problems that deep learning is still trying to solve that hasn't been done yet? So like, just like in general, any problems that haven't been covered by an algorithm yet?
So like right now at the cutting edge is like self-driving vehicles. But that's kind of incorporating a lot of known stuff about deep learning tech, such as like object detection and making inferences on that. So object detection and recommendation systems, those are all within the realm of deep learning and machine learning too. I don't think I want to get there. I want to do a PhD so I could be at the cutting edge and I could give you a really good answer, but I can only tell you what stuff I do know deep learning does, and that's like object recognition, recommendation systems, natural language processing, self-driving vehicles, other things like that. I mean, you might, if you talk about the future, maybe you'll have like completely autonomous drone technology that like uses the camera, and they're able to like be by themselves and make inferences about what to do. That's probably something that'll happen in the future. But yeah, wish I could give you a better answer.
No, I think that helped a lot. And then just wrapping up, is there like any advice that you would give to anyone here just to get more involved in the just to get more involved in this, what we should do, learn?
Yeah, like I said, I think prior to this talk, I'm very surprised that I understand deep learning, because like once I've actually like took the class and I kind of look back on all of the stuff I had to learn linear algebra, I had to learn multivariable calculus, I had to learn probability theory, all these different major schools of mathematical thought. And by no means am I a master in them, but like I had to understand them a little bit to understand deep learning. So I wouldn't feel in a rush necessarily or feel bad at all if you start trying to learn deep learning and you feel a little overwhelmed. That being said, I think that if you have if you have like done calculus and you know a little bit about calculus, you're on the path to understanding deep learning, and it definitely is attainable. If you want to look into, you should look into tutorials about it. You can look into videos about it. There's a Python, there's several Python libraries that are built towards deep learning. One of them is called TensorFlow. That one's by Google, and that's the one I prefer. There's another one called PyTorch. These are all Python. So you could go through those tutorials, and I think that you would be able to actually write some of these programs without having to know the math. But I don't think that I think in order to become a good deep learning engineer, you would have to understand what's going on in the background.
Joyce, was there any more questions?
No, I think that's pretty much it.
Okay. So we just want to say thank you on behalf of the CS First Club, AI Club, just of everyone who came here. Thank you so much for taking this time to talk with us. I think a lot of people got a lot of this, like a lot from this, just about like general information, theoretical science, AI. So I just want to say thank you on behalf of everyone here. This was incredibly helpful, and
More than happy to help.
Thank you. And good luck on all of your, I know you have like finals, projects, stuff. So
yes.
Good luck on the projects.
It's time to grind.
But if we have like future questions, could we like email you, or do you?
Yeah. I can share my email. I don't know where the best place to do that is.
Put in the chat.
Yeah. I can like give it to Joyce too, and Joyce can.
So I'll put it in the chat.
Yeah.
And then yeah, feel free to circulate it, I guess.
So I think we're gonna stay on for like 2 more minutes, but that's the end of it. Thank you all for coming. Yeah.
Cool. Thanks, guys.